NASA's Explorer 1 shuttle, the farthest voyaging shuttle ever sent off, continues its stunning journey through the universe for nearly 50 years. Explorer 1 has been sending back vital data from the farthest reaches of the universe, altogether propelling our understanding of the universe. However, recent transmissions from this remarkable rocket have presented baffling signals that have left the entire space community in a state of wonder and bewilderment. These signals have sparked debates about whether they are the result of a technical error or if they could be indicative of something far more extraordinary, such as extraterrestrial activity. Join us as we delve deeper into the mystery surrounding these remarkable transmissions and uncover what might be hiding in the depths of space. Humankind's fascination with the mysteries beyond our planet has been a driving force in space exploration since its inception. This insatiable curiosity led to the historic launch of missions like Voyager 1 and Pioneer 2, which were among the most ambitious space endeavors of their time. The launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just 2 weeks later, on September 5th, Voyager 1 followed, paving the way for an extraordinary venture. These twin spacecraft, each weighing around 720 kilograms, roughly equivalent to a small car, were launched during a rare alignment of the outer planets, which played a crucial role in their trajectories and mission outcomes. Throughout their remarkable odyssey, these rockets traveled in disparate directions and at different speeds. A significant moment occurred on December 15, 1977, when Voyager 1 surpassed its twin due to differences in their paths. Since then, Voyager 1 has emerged as an invaluable asset, providing priceless information that has revolutionized our understanding of the universe and its myriad phenomena. Before we dive into Voyager 1's latest astounding discovery, which has captured the attention of the entire space community, let's revisit some of its most exceptional accomplishments. In 1978, during its Jovian imaging mission, Voyager 1 was positioned about 265 million kilometers from Earth. By January 1979, it had embarked on a grand 100-hour mission, capturing a mesmerizing time-lapse film of Jupiter's rotation. This series of 3,750 images offered unprecedented views of Jupiter's dynamic atmosphere and its complex dynamics. The spacecraft's findings included the discovery of a small ring around Jupiter and 2 previously unknown moons, greatly expanding our knowledge of the gas giant's intricate system. To ensure the spacecraft's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn mission, scientists decided to conclude the planetary missions of both Voyager 1 and Voyager 2. However, the spacecraft were sent on a new trajectory beyond the boundaries of our solar system, traveling at an astounding rate of 325 million kilometers each year. In January 1990, the interstellar mission began, with Voyager 1 continuing its celestial journey. During this period, Voyager 1 made significant discoveries, including the identification of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea. It also captured some of the most iconic images ever taken of our solar system. On February 14, 1990, Voyager 1, positioned approximately 6 billion kilometers from the Sun, embarked on a visual journey known as the Family Portrait, capturing stunning images of the solar system's planets. This collection of 60 images added to Voyager 1's impressive array of 670 photographs taken during its encounter with Neptune. Voyager 2 also achieved remarkable accomplishments during its mission. As it approached Neptune, it recorded wind speeds exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. This achievement provided valuable insights into Neptune's distant atmosphere and its largest moon, Triton, with surface temperatures dropping to a frigid -391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also exhibited unique features, including ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its hazy atmosphere. These extraordinary findings have expanded our understanding of the diverse and complex nature of celestial objects in the outermost regions of our solar system. The Voyager missions have delivered invaluable and unprecedented results. Voyager 1 and Voyager 2 have revealed that Jupiter and Saturn's moons, once thought to be heavily scarred and dormant, are actually teeming with geological activity. Voyager 2, in particular, achieved several historic feats, including being the first spacecraft to fly by Uranus and Neptune, and remains the only spacecraft to have done so. NASA employed various strategies to extend the operational lifespan of these ambitious spacecraft, including shutting down unnecessary heaters and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a touch of melancholy for the scientists and engineers who have dedicated themselves to this extraordinary endeavor. The design of Voyager 1 and Voyager 2 was a marvel of engineering. These spacecraft were designed as stable platforms, spinning at a rate of over 2.5 revolutions per minute, ensuring accurate data transmission and reliable performance throughout their mission lifetimes. Multiple times slower than a clock's hour hand, this planned decision decreased visual obscuring as the rocket crossed the immense region of space. Even before reaching the outer planets, the rocket began sending pictures of Jupiter, revealing its swirling clouds and famous features. The Great Red Spot, a huge storm on Jupiter, captivated crowds at NASA's Jet Propulsion Laboratory. However, the discovery of active volcanoes on Jupiter's moon Io garnered the most attention. The shuttle's instruments detected unusual signals from Io, which were confirmed by exceptional pictures showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most distinctive volcanoes erupted with a power multiple times greater than that of Mount St. Helens, covering an area nearly the size of France. As the rocket continued its journey, its cameras were eventually switched off to conserve power and memory before it ventured into interstellar space. Remarkably, the pictures they captured did not include Mercury and Mars for multiple reasons. Other than the Voyager probes, NASA has launched other remarkable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11, becoming the spacecraft farthest from Earth. Despite the absence of other space probes to observe it, Pioneer 10 continued its solo journey for 14 additional years before entering the interstellar environment on August 25, 2012. The success of the Voyager missions was made possible through various innovative techniques, with gravity assist maneuvers standing out as particularly brilliant. These maneuvers were crucial for propelling the spacecraft to their distant destinations and gathering valuable data. The spacecraft relied not only on their own propulsion systems, but also on gravity assists to achieve their goals. Imagine the two brave rockets smoothly navigating through our solar system using the gravitational pull of planets to propel themselves forward. This celestial dance allowed them to conserve fuel and achieve the necessary speeds to visit various locations. Gravity assist maneuvers involve providing the shuttle with a small amount of a planet's energy as it passes by with extreme precision. For instance, as Voyager 1 approached Jupiter, the planet's significant gravitational attraction sped up the spacecraft, increasing its speed. Achieving such precision was crucial. Any deviation from the correct angle or speed could have resulted in an unfortunate outcome. Despite the overwhelming precision required, the brilliant minds behind these missions successfully executed these gravity assists multiple times, sending the shuttles on an extraordinary journey. The Grand Tour, made possible by these celestial maneuvers, saw Voyager 2 using gravity assists from Jupiter and Saturn to reach Uranus and Neptune. The success of the Voyager missions owes much to these gravity assists. As we consider the incredible journey of these exploratory spacecraft and the wealth of data they have provided, we eagerly await further updates on the investigation into Voyager 1's recent anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond the boundaries of Earth, and their achievements include exploring Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Voyager 1's time-lapse images highlighted 10 rotations of Jupiter in striking detail, including the discovery of new moons and a small ring. These findings have greatly enhanced our understanding of Jupiter's complex system. Voyager 1 also discovered 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took stunning photos of Saturn and its rings, providing new insights into Saturn's intricate system. The rocket made history by visiting Uranus and Neptune and providing valuable data about their atmospheres and moons, advancing our understanding of the outer regions of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the cosmic environment. This ongoing exploration continues to expand our knowledge of the universe beyond our solar system. As we anticipate more information about Voyager 1's latest signals and their potential implications for our understanding of the universe, the astounding journey of these spacecraft remains a source of inspiration and curiosity for scientists and space enthusiasts alike. Accomplishments keep on pushing the limits of human information and investigation, featuring the vast capability of space exploration. The Voyager missions have given us a mother lode of data about our planetary group and beyond. The notable pictures and data the shuttles have captured also include a unique artifact designed to convey the tale of our world to extraterrestrials. This record contains sounds and images meant to depict the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds such as thunder and whale songs. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they might find and understand it, offering a glimpse into humanity's essence. Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our understanding of space. These instruments include magnetometers, plasma wave detectors, cosmic ray instruments, and imaging systems, each contributing essential data about space phenomena. For example, the magnetometers have provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surroundings. The plasma wave detectors helped us understand the nature of the solar wind and its interaction with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that encloses our planetary group. As Voyager 1 approached the edge of this boundary, it detected a sudden change from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in protecting Earth from cosmic radiation. The rocket's observations have provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally notable. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide valuable data on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly striking for revealing its unique magnetic field, which is significantly tilted compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and spurred further research into the magnetic conditions of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the personal narratives of the rocket's journeys, have captured the imagination of people around the world. The images of Saturn's rings and the detailed views of Jupiter's moons, particularly Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. These missions have fostered a sense of wonder and curiosity about the universe, highlighting the importance of exploration and the quest for knowledge. The engineering and logistical accomplishments achieved by the Voyager missions are also significant. The rockets were designed to operate in extreme conditions far from Earth, with temperatures dipping below -220 degrees Celsius. They rely on radioisotope thermoelectric generators, RTGs, for power, which provide a consistent energy source despite the immense distance from the sun. The engineers who designed and built these rockets faced numerous challenges, including ensuring that the instruments would remain functional for many years and that communication could be maintained over such vast distances. The data returned by the Voyagers has also impacted our understanding of the broader cosmic environment. The shuttles have helped map the distribution of cosmic rays and have provided insights into the density and composition of interstellar dust. This information is crucial for understanding the conditions in the space between stars and for preparing future missions that could explore other star systems. As the Voyagers continue their journey into interstellar space, Their legacy is established not just by the data they have already provided, but also by the inspiration they offer for future exploration. The missions have paved the way for new technologies and techniques in space science and have set a precedent for ambitious, long-term space missions. They demonstrate the possibilities of human creativity and the value of persistence in the face of daunting challenges. Looking forward, the Voyager missions have inspired a new generation of spacecraft and mission concepts. Future probes aim to build upon Voyager's achievements with the goal of exploring even more distant regions of space. These upcoming missions will continue to push the boundaries of our knowledge and will benefit from the foundations laid by the Voyager spacecraft. In conclusion, the Voyager missions represent one of humanity's greatest accomplishments in space exploration. Their contributions to science, their role in advancing our understanding of the solar system and beyond, and their impact on public imagination highlight the importance of continued exploration and curiosity. As Voyager 1 and Voyager 2 journey further into the universe, they remain symbols of human aspiration and the endless quest for knowledge.